Hello everyone, and welcome. This is the first video of a 3 or 4 video series about 3D printing. This first video is all about slicing. Specifically, in this video I will be using Cura and most of what I use and explaining what it does. Now, I think that it's important before we even get into this video that you have an idea of what a slicer is. A slicer is a piece of software that turns our prints into basically a layer by layer format and telling the printer where to move the nozzle. So, without further ado, let's get into the slicing section of this video. So, just to start our slicing portion, I opened up Cura with the profile of Flashforge Creator Pro. Now, let me first import my files. So for today, I'm going to click on this file button. So for those of you who don't know, this will be like a guide, and I'll just search up Benchy. Now it's going to appear STLs. Now this is very important. You can use STLs. Here you can see all supported types, STL, PNG, G-code, all this stuff. However, you're going to want to import an STL. This is a 3-dimensional mesh file. So what I'm basically importing is this mesh. It's running a little. Yeah, here's your mesh. So what I'm doing right now is part of a step called slicing. In this piece of software, you are trying to convert this shape, this Benchy shape, it's a 3D shape, into lines. You slice. Whenever this is slicing, it's just going to, there's a little bar in this corner, and this will give you an indication of how far along the slicing is coming, but once I slice it, you'll see what it looks like. Okay, so this is what it looks like when it's been sliced. This here is the layer view. So if I want to see what my layers look like, so I use this a lot if I'm curious about what it's going to look like, or if I see any issues, more importantly. You can see what the 3D printer is doing layer by layer. And then here just is the path of the nozzle. So here here is your nozzle, and it's going around the shape. You can see it's going out in circles. Now, I'm going to go back to prepare. That's the end product of what we're doing. And in prepare, we have there's a lot of settings, but I'm going to try to keep things simple. Okay. So these are just the most basic profiles. So layer width, so this is how wide your layers are going to be now. So the way this works is it's adjusting the amount of flow. So in this instance, I have a 0.4 millimeter nozzle. So I set this to 0.4. However, setting it to 0.5 will just deposit more filament onto the build plate, and it'll make a wider width because you're depositing more volume of filament. The layer height is 0.15 millimeters. This is important. This is what makes the quality of this surface good, because as you can see, this is just smooth. if you have a really small layer height, like 0.1, it's going to take longer because you're trying to make these little itsy bitsy tiny, but your things, but it's like stacking. Like if we say this is like a layer line that's like 3 millimeters thick, then basically what the printer is going to do is it's just going to deposit the filament on the bed, or it's the filament that's already been deposited, and it'll deposit in this like way. It's kind of like stacking on top of itself. Next, walls. This is not important. This is optional. I would say, like for the beginner, I would say do research on how to use this, because it's useful to know how many lines you want in your wall, but not always. Top bottom. This is enable ironing. Ironing is where the filament head, the extruder nozzle, the nozzle will just go above it and deposit a really thin line of filament and melt the filament beneath it. The whole goal of this is to make a shinier surface. In this Benchy, this is not necessary because it'll only happen on the top layer, which is this stack, and it's a waste of time if you're doing something like this. Infill density. This is very important. Infill density, there's a range of around 5 to 18%. Now, I like to set it to 10 to 15%. So 15% of this whole shape, which is not a wall, so like the inner profile will be 15% of that will be filled with the grid pattern, as you saw at the beginning. These three are important. All four of these are quite important. I mean, the last one's important only if you're doing dual extrusion printing, which I would be, but I only have one shape, so I'm going to disable this extrude because I have a 3D printer that has 2 extruders to it, which is awesome. So now that I've disabled this extruder, this is an important step in slicing because otherwise it's just going to heat up and ooze filament. Now, I'll go over that later on in this video, what oozes and how we can combat this, because this is really what this applies to are dual color 3D printers, dual extrusion 3D printers. So I would say most of you guys probably will have a single extrusion model printer with one nozzle. Instead, my printer has 2 separate nozzles and 2 separate filaments. So I can, I could make a print and say, have a layer that's blue, or a layer, and have an extruder that's extruding this filament. It's a flexible type material, and use PLA in the other. Next is, as I said, printing temperature. This is what determines how hot your nozzle is going to be. In this case, I am using rainbow color changing PLA. It's the stuff that this is made out of. It color changes as you go through the length. However, you want to ensure one thing, is that it's going to, obviously you want it to melt in the end, but you don't want it to be too viscous. So this setting, what it will do is you're basically telling your 3D printer, hey, this extruder needs to heat up to 220 degrees Celsius, or hey, this build plate needs to, we need to make sure that this is 60 degrees Celsius before printing. If you have too cold of a printing temperature, so if I set this to like 215 would be fine, but if you have below, in my experience, I've never experimented with this below 200, but I know at 210, the bonding isn't the best. It has a better finish for bridges, but it's really not the softest. It's not that easy to extrude because you're forcing more. You're more forcing in than anything else. But just remember that these are all really hot. This is around twice the boiling point of water, so touch it and you burn yourself almost instantly. This brings us to flow. This has to do with our material here. So as we're extruding this is like the rate that you're pushing this material in. If this is like normal feed rate, then if you speed it up, then you're going to be pushing more material into the hot and thus depositing and melting more. I set this to 100% at 220, but you might have to 3D print at 230 at 150% because have in mind when you're 3D printing, you have to melt the filament, obviously. That's how you make it. If you're resin 3D printing, this doesn't matter. Right now I'm just changing the profile. This is a wood profile. So this is optimized for my wood prints. But again, just 15% infill. Oh, this is glitchy. This is 15% infill, the same settings as before. 60 degrees Celsius. I like to use 60 degrees. I like to use a heated bed that is 60 degrees Celsius. Now, there are printers without heated beds. This is since I'm using PLA or polylactic acid, corn derived. You do not need a heated bed for it. Now, if we're talking about ABS, which is an oil-derived plastic, this is mandatory because ABS, I've never printed with ABS, but I've seen ABS prints where they go sideways because the bed isn't heated and the cooling it just cools too quickly. When you cool ABS too quickly, it'll bend. It'll warp. So now speed. This is important because you do not want to max out your 3D printer. You don't want to be running at max speed. This could risk getting shaking artifacts. Now, I've had several 3D prints with these said shaking artifacts I've discovered. This is one of them. It's a cube, but you're going to see around the Y, if I can just... Around this Y, there are artifacts. So there are these like shake. You can see a little bit of shake. I hope at least you can see that there's some amount of shakiness in this side of the Y. It's ringing, I believe is what it's called. But this is what happens when you run at a fast speed. When you're running at a fast speed, you have to have in mind that with my printer, you have to have in mind that you're accelerating that extruder assembly. So, as with anything related to physics, you don't want to have you have to slow that down, and when it's slowing down, it'll shake a tiny bit, or it's just. And when it does like an oscillating motion, it'll shake a tiny bit because you're trying to accelerate the mass to this location, but then you're trying to decelerate it exactly there at that location, and that doesn't happen in real life. Since I have, with the 3D printer I have, you need the maximum speed is 100. I generally will put 100 or 80 millimeters a second for travel speed because I do not, again, I want to make sure it doesn't skip. I've had it where you can see there's a layer shift, and I believe that is because of shifting. Now, the next profile is, this is called travel. This is really, for the settings I've used, there are so many settings in Cura. Like here, just take a look. You can see that there's a lot of these settings. I only use retraction distance, retraction speed, and Z-Op retracted really isn't necessary. However, sometimes anti-ooze retracted position is always good. Here you can see under material, anti-ooze retracted position. I use it because I'm trying to prevent one thing, oozing. Oozing is where the idle extruder will just, material will still drip out of it. It's like water dripping from a leaky faucet. It basically just deposits these balls on your print. Now, I have an example of this here. This is an extreme example of what ooze looks like. But you can see that there are these, basically here there are these ooze, these just bulges in the material. Now, this is important because if we look at this print, this is a very slow print. You'll see that I'm only using one extruder for this. So you will see some shaking artifacts from it shaking a tiny bit here, or inconsistencies, but this is normal. Like in my experience with this print, I see these small like lines in it vertically. I'm not sure why. I think it may be due to some really small amount of shaking. But otherwise, speed will help. So let's move on to retraction. So what retraction, let me just close some of these tabs for you guys. Okay, retraction. Retraction is, as I said, it's like stopping the leak in a leaky faucet. You're trying to, when you're dual extrusion 3D printing, as I mentioned, you will have one idle extruder regardless. This is also useful for within your print. So sometimes I've had it where there is ooze from the other extruder. Regardless, I generally set it to 4, 3 or 3.5 to 4, because I found that it stops some of the ooze, but never completely stops, which is really quite annoying. But if anyone, comment below if you guys know this. The 3D printer is up in the corner here. Not sponsored by this company, so next is cooling. Now, cooling is what's controlling your part cooling fan. As you can see, the speed at which the cooling fans spin affects regular fan speed and maximum fan speed. Now, 100% is the part cooling fan going full blast. I would advocate for, I haven't printed with PETG, but I want to get some. But for PLA, you want to ensure that you have good cooling, because you don't want it to be really goopy. Like, it'll turn to this goopy type feeling if it's not on 100%. Next is support. So if I turn on generate support, you're going to see a lot of settings. These are all settings I select. So here, I'm just going to get rid of some of these to help for the beginners, to give you guys an idea of, or just people who are curious about this. I want to try to see if we can make this as simple as possible, because there's a lot of settings related to this support. Okay, so this is what I'm normally using. This is normal. Support structure, you have normal and tree. Sometimes I'll turn on support pattern. This one, I don't use it too much, but it allows you to control what type of support you get. Normally, you'll see zigzag. This is quite a normal setting. Now, this is an important one. Support's really important, obviously. We want to ensure that our prints are not going to have any type of just, we don't want to have our prints turn out that there's some artifact because it's just drooping under the weight of gravity, obviously. That's why we have support. Oops. But what's important is in order for those supports to be made, we have to ensure that there's a good mechanical connection to, there's a good stickiness. This material, in other words, you want this material to stick to your build plate. Now, there are 3 types of build plate adhesion. 4 types, actually, but none is not. 3 types. We have skirt, brim, raft, and none. First, I'm just going to slice this to illustrate, to show you guys what this looks like. So here we have a benchy. I'm just going to slice this because this is in preview's going to show us what this really looks like. Perfect. Okay. Here's what it looks like the support's on, but this layer on the outside here that I'm tracing, this is the skirt. The purpose of this is to purge the nozzle before we start printing the actual object. So let me go down to the first layer. Okay. So here's the support. This is just your zigzag support, but here. So this is the first movement. As you can see, this nozzle is just tracing that skirt. Now it's going into the actual object and printing that first layer. But as you can see, that obviously was just to purge it out. Brim. This is the second option. This option is very similar to a raft, but it's not, it's just on the outside. I'll show you what I mean once I get this because I don't want to be too misleading. Okay. Perfect. So here's our first layer with a raft. A brim. Let me just show you the full object. So, skirt was just that one layer. It was just that one loop around. A raft is a brim is totally different. So our first layer view now looks like this. Instead of going right round, it's tracing the outline, but in the end, this is the brim is trying to connect to the object. So this is actually connected to the object, which is, it's nice if you want to use it, but it's not really a fun option to remove because it's just on the object. It's fused to all this brim is fused together. So when you're trying to remove it from the object, here's the actual benchy right here. It just goes right round like that. That's just the actual first layer of the object. Now that brings us to raft. This is, in my opinion, the better of the two between brim, because raft is a lot easier to remove. Because the raft itself will peel back from the object, whereas the brim is fused to the object. Which is a pain in the butt, but sometimes you want to minimize material, and that's where you have a brim. A raft is totally different. Whenever I go into, let me just go back here. First layer. This looks really weird because in all these examples that I've showed you, the brim and the skirt, these are all one layer thick. This raft is not one layer thick. It's a lattice. It's like a lattice. So this first one layer is it's just trying to give a lot of surface area to grab onto the build plate. The second layer is now just trying to make a poor it's a way that they're trying to connect the model to it. And this is just solely for just making sure the model sticks. Because once you're done, it's going to disappear. Now here's the third layer. This is a much tighter than the second layer. So here's the second layer. It's similar to the first layer in that it has a similar lattice structure, but it's much tighter in terms of structure is now vertical. Finally, this fourth layer. This is whenever you're building up to the fact you're trying to get the model printed. So this is towards the model, and now fifth layer is where the model itself starts. And you'll see that this is your first layer for the model. So here you can see these are all supports on the outside. This is the actual first layer. Let me go back one. Actually, this is the first layer. But if I go back, you'll see that these are all the supports that are being made. And this is connected to raft. Now, have in mind that when you're using a raft, it is a very easy thing to remove. Rafts are very easy to remove most of the time, unless you use such a high nozzle temperature that it literally fuses itself together. Because most of the time, the raft is just going to peel off with very little effort. And those are the three build plate adhesion types. This brings me to these three modes, but I'm not going to go over them in this video because I'm trying to make this simple. I might go over dual extrusion, but there's no use. I mean, if I go, because this is a single, I've disabled this extruder here. So number 2 is disabled. So I can't do it. So in summary, here are the settings I'm going to use for this model. I'm going to modify them a little bit. First of all, I'm going to try to support. This is what we call a Benchy. This is a diagnostic print. It will test the precision of your 3D printer and its ability to do a lot. So look up on Benchy's website, 3dbenchy.com. They have built in so many different calibration tools. One of them happens to be the text in the back. Don't know if you guys can see it. One is this hole, and I know that these all are overhang tests, as well as this top chimney being an accuracy test. So there's a lot happening. Now I'm going to turn bed plate adhesion to skirt because it uses very little filament. And so now on our second install, so this is going to be a series I'm making. So this is part 1 that you guys are watching. This is all about slicing. So what we went over is the slicing process. We import a model, and just go over it. We press this button to import a model. Select it from our hard drive or flash drive or wherever. We change the settings to what we want. Printing temperature normally for this filament will be 220 degrees Celsius, which is a bit high for PLA, but it's recommended by the manufacturer. this model does not need support because this is a diagnostic model. It is used to help aid you making better settings. This is why I like it. It's a relatively short print. It's only an hour, 90 minutes long at the speeds I'm using. Actually, I'm going to change the speed. Speaking of speeds, I'm going to change this to around 80. And now slice. This button is what, does the magic, if you will. It turns this one profile into those little layers I showed you and relays it in turn to the 3D printer. Okay, this is good. An hour and 18 minutes long, so that's with our settings. So here's what it looks like now that it's sliced. These layers are just, you can go back if you go through. This is all controlling the layers, so you're going to see that, you'll see that infill, all this. This text is really important in the bottom though. See this text? This is very important because this is part, again, of the diagnostic. It's trying to assess how, it really shows you how melty the filament is. Here's one of my prints. This is a purple silk PLA. And you can see, I don't know if you guys can see, but there is basically this, the text didn't come out well at all. So that tells me that my setting may have been too hot. That's the way I interpret it. But this circle came out really well, as well as this thing, I don't know what it's called. But this part of the Benchy, this chimney, is how you can assess accuracy of your 3D printer. Which is really important because you're obviously going to be given specs. Your 3D print, they should give you specs. The company should give you specs. But it's important just to see how precise it is in general, in practical use. In your practical use. But anyway, this was our video for the slicing portion. The next video will be all about turning. It's almost done, actually. All I gotta do now is save this to disk. And my printer doesn't use G-code, so. And save to disk. Oh, no. And that was it for today's video. I hope you